Good evening, guys. So I found a way that I could help you guys out um, going through these PowerPoint or the notes on the mole. And the best way that I could help you guys out is by going through it together and making sure that you guys are good to go. Okay, so just to go step by step here. So the first part, mole concept, the entire concept of the mole is a mole is a unit of a specified number. Okay, so number of particles that chemists use. So remember, I told you guys in class that the when we're describing particles in an atom and such like that, we're able to say that it's either a lot of atoms or molecules, or we could say that it's a mole, or we use mole to kind of jumble all those large numbers together. All right. Um, so let's keep going. Just like bakers use uh, I know a lot of you guys wrote dozen. So that did fit right here. So we could just write dozen right in here to specify 12 items. All right. And here a mole is equal to blank particles. The mole is equal to 6.02 times 10 to the 23rd power right up here. All right, and this number is referred to as the Avogadro's number. Okay, so make sure you guys know that Avogadro's number. Okay, so here the mole conversion. So there is a number that we use that we will be using quite often, um, and I'm sorry, I was getting sidetracked there. So here, what we got to write is for 1 mole, it's equal to 6, like we wrote over there, 0.02 times 10 to the 23, and the conversion factor is 1 mole over 6.02 times 10 to the 23. Or we could write it upside down, okay? Because remember, when we're doing these problems, we could be using either of these conversion factors, okay? In the example problems that we'll be doing today, they will be utilizing either of these two conversion factors, okay? So just heads up. So in this first problem that we have here, let's see, let's do that. Let's go in there. Sorry guys, this is the first time I'm using these functions of a writing pad, and it's pretty neat, but it's just a little confusing at times. So bear with me. Let me erase this. All right, that looks nice now. Okay, there we go. Go back in there. Perfect. Okay, so for the first example, I know we did this in class already, but what do you need to know before we solve this in order to solve this problem? The example is, how many dozens is 6 donuts equal to? So first of all, how many items are in 1 dozen? So in this case, how many donuts are in 1 dozen? So from earlier's example, or from the notes, we wrote down that 12 is equivalent to 1 dozen. So here we could turn this into our conversion factor. Okay, and the way we do that is we could write 12 donuts is over 1 dozen. Or we could write the 1 dozen on top and then the 12 donuts on the bottom. Okay, so this helps us be able to utilize both this conversion factor as one way or the other. Okay, it just depends on what's being asked in the problems. So since here it is stating that we have 6 donuts first, then I'm going to write down my 6 donuts in our space here. So what we're going to start off with is 6 donuts right in here. So I have 6 donuts. Okay, and we have this over 1. Then we're going to multiply that by the conversion factor. The conversion factor that we're going to be using is that since donuts is on top and we want to go from donuts to dozens, I'm going to use the conversion factor where dozen is on top. Okay, so we want to use the conversion factor where the unit we want to go to is on top of the numerator. So we're going to use the conversion factor, the 1 dozen over 12 donuts. By doing this, we're able to cancel out our donuts, units, and then we're able to punch this into our calculator. So we could do 6, this turns into 6 times 1 over 1 times 12. And then we're left with donuts. Dozen, pardon me. So then this turns into 6 divided by 12 dozen, or it goes to 0.5 dozen. Okay, so here's the overall shots of this problem. So again, what we did is that we wanted to go from donuts to dozens. So in order to do that, we had to set up a conversion factor. In this case, we knew that 12 donuts over 1 dozen is one way to represent the conversion factor, or we could utilize the 1 dozen over 12 donuts. Okay, so in this case, since we want to go to dozens as the new unit, we use the conversion factor dozen that's on top. Okay, and that's for us to be able to cancel out the donuts on the units from the initial units. Okay, so let's move on to the next example. All right, so next what we have is that we want to see how many moles of magnesium is 1.25 times 10 to the 23rd atoms. Okay, so when we do this, now we want to go from atoms, we want to go from there, we want to go to moles. Okay, so when we're doing this, we have to use another conversion factor. Okay, so from earlier, we learned that 1 mole is equivalent to 6.02 times 10 to the 23rd. Okay, in this case, we're using atoms of magnesium. Okay, and then the other way we could write it is 6.02, whoops, that's a 0, times 10 to the 23rd atoms of magnesium. Okay, and on the bottom here will be 1 mole as well. Okay, and we have to include magnesium as well. We can't forget that. We have to start off right, guys? Okay, so instead, like the same example as the donuts example, we wanted to go from donuts to dozens. So in this case, we want to go to moles as the new numerator. Okay, so in order to do that, we have to have moles on the top of our conversion factor. Okay, so in this case, the one that we want to use is this one because moles is indeed on top. Do you see this right here? Moles is on top. So then as we do this, we got to go, let's zoom in a little bit, there we go. So we write down what's given, and what's given is 1.25 times 10 to the 23 atoms. So then what we write is 1.25 times 10 to the 23 atoms of magnesium. Okay, we put that at over 1 because that's the numerator. And then we're going to multiply that by 1 mole of magnesium over 6.02 times 10 to the 23rd atom.